Alright, today we're talking about sketching graphs, so just going to roll through a few of these and, see how we're doing and kind of, get some out there. Alright, so first key thing is we're looking at a 6-degree function. Alright, 6-degree function. So as I assess the roots I have rad 8, which we all know means we also have negative rad 8. I have 5, I have negative 8, and I have negative 2i, which means I have positive 2i. So the key thing about a 6-degree function is there has to be 6 roots. Do we have that? 1, 2, 3, 4, 5, 6. Yes. All right, so it's time to start building the equations for these. So 5 I know comes from x minus 5. Negative 8 comes from x plus 8. All right, so if I did sum product over here, sum is 0, product is 4, x squared plus 4. If I did sum product here, sum is 0, product is negative 8. So that gives me x squared minus 8. Alright, so there's my equation. That has a 6-degree function with a positive lead coefficient and exactly 4 real zeros, including those, and a negative 2i. Alright, now we got to sketch. So we know 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, negative 8. Now the key thing with the rad 8 is basically just what's the decimal? Well, rad 4 is 2, rad 9 is 3, so we're talking about 2 point something for rad 8 comma 0. And we got negative 2 point something for negative rad 8 comma 0. Alright, last key thing, if we plug in 0, we get our y-intercept of 0, 1,280. Alright, positive lead coefficient means it's going up. Even degree means it's going up. They're all pass-throughs in this situation to give me that sketch. Now, I've spoken to a handful of people about this. The imaginaries, if you want to, you don't have to. You can throw that extra wiggle in there if it makes you feel good. Not every graph with imaginaries has that. Some do, some don't. We don't necessarily need it. I'd be okay if you didn't have it. Alright, there's problem 1. Problem 2, a 9th-degree function with a negative first coefficient and all non-real complex roots. All non-real complex roots. So what that is saying is we have imaginaries and we have rads. Now, what is the issue here? 9th degree means that if we're going up here, we're going down here. So at some point, we have to pass through the x-axis. All non-real complex roots. Since this says all non-real complex roots, oops, I wrote rads. Can't even be rads. My bad, just imaginaries. Alright, so in this situation, what it's saying is all non-real complex roots are all imaginary. So imaginary roots aren't going to touch the x-axis. So if this said even degree, this could work. We could have a sketch like this. But the fact that it's odd, it has to pass through the x-axis, and since we don't have any actual x-intercepts, there is no answer to this one. So since we have all imaginaries, it's not impossible to have 9 imaginaries. You can have 8 imaginaries, you can have 10 imaginaries, can't have 9 imaginary roots. Alright, what do we got here? Quintic, meaning degree of 5. So we only have 2 roots, and those 2 roots are 1, negative 1, which comes from x plus 1, and 5, which comes from x minus 5. Right. One common thing people seem to do, I've noticed a handful of people, is they just make up extra roots. We can't make up extra roots. We only have 2 distinct roots. Right. We can't make up imaginaries, we can't make up rads, we just have these 2 roots. So what that means, there's multiple answers here. We have to get a degree of 5. There could be 4 5s. There could be 2 negative 1s. There could be 3 5s. There could be 3 negative 1s and 2 5s. There could be 4 negative 1s and 1 5. All acceptable answers in this situation. Now, it doesn't matter which one you choose. In the end, just pick it and graph it. So if I went with this one as my actual answer, I got negative 1 as a root, 1, 2, 3, 4, 5 as a root. My lead coefficient here is positive, degree of 5, going opposite directions. Touch and turn at 5, pass through at negative 1, figure out my y-intercept, 0, 25. Now, taking this even further, does it even talk about lead coefficients? All right, doesn't talk about lead coefficient. Nowhere does it say it has to be a positive lead coefficient. So we could have made these all negative. So really I got 8 different examples. If this was a negative lead coefficient and I graph this, here we'd be going down, touch and turn, pass through, 0, negative 25. All right, so whatever you want. In these situations, sometimes there's multiple correct answers. I know that stresses people out sometimes, but it's okay. Whatever works is fine with us. Even taking it a whole nother, you could throw a negative 2. You can make this 1/2 as lead coefficient. Doesn't matter what you have as long as you have a quintic function with exactly 2 distinct roots of negative 1 and 5 and no non-real complex roots. That's what we gotta have. Problem 4. Right, quartic function with exactly one x-intercept of 4 and at least one non-real complex root of 3 minus I. Well, then we got 3 plus I. Right, so if we go sum product here, sum is 6, product is 9 minus 3i plus 3i minus I squared for 10. So we got x squared minus 6x plus 10 for this. Key thing, quartic. So what does that mean? Gotta have 2 4s. Right? Always gotta make sure we have the correct, in these situations, correct degree based on what the problem's saying. Now again, this one doesn't tell us anything about the lead coefficient. It could be positive, could be negative. Right? Whatever works for you. In my situation, I'm just going to leave it the way it is. 1, 2, 3, 4. All right. It's a positive lead coefficient's going up. I got 2 4s. I got my touch and turn. Pass through here. What point is this? In this situation, it's 0, 160. If you want to throw the wiggle in for imaginaries, if you don't, fine. All right, so if you're a wiggle person, go ahead. If you don't want to do that, don't do it. Now, with the wiggles, does it matter where the wiggle goes? No. Put it wherever you want if you want to throw it out there. All right. 5. 7th degree. Positive lead coefficient. All right, this one's telling us about the lead coefficient. And exactly 5 x-intercepts, including rad 3, which means we have negative rad 3. 7, which means we just have 7. And negative 2 plus rad 5 would come into this situation. All right, so do we have 5? 1, 2, 3, 4, 5. Perfect. All right, so from here, right, sum 0, product negative 3, x squared minus 3. From 7, what do we got? X minus 7. Sum, negative 4. Product, what do we got? We got 4 minus 2 rad 5 plus 2 rad 5 minus rad 25 for negative 1. X squared plus 4x minus 1. Okay, what's the issue? 7th degree. All right, so we got to modify this in a way. Well, right now, I have a degree of 2, 1, and 2. So I got to put my other 2 out there somehow. My personal choice, I would make this an x minus 7 to the third. That's an acceptable answer. But there are many other, not many, there's, two other options that are sticking out in my head. Y equals x squared minus 3 squared, x minus 7, x squared plus 4x minus 1. So this has a degree of 4, this has a degree of 1, this has a degree of 2. There's my 7. Right. Other option, y equals x squared minus 3, x minus 7, x squared plus 4x minus 1. I can make that squared. And there's my 4. Right, so, every option works. Not everyone's going to have the same answer every time, and that's okay. Which am I going to graph? Let me go with the first one. Right, so I got 7. 1, 2, 3, 4, 5, 6, 7. I got rad 3, which is 1 point something. I got negative rad 3, which is negative 1 point something. I got negative 2 plus rad 5. Negative 2 plus rad 5. So I got negative 2 plus rad 5, negative 2 plus 2 point something. So I got a really small number here. I'm going to put that one there, and its counterpart there. Oop, not there. So I'm going to say that's my tough label. I'm going negative 2 plus rad 5 comma 0, while negative 2 minus rad 5 puts me at about 4 something. 1, 2, 3, 4. I throw negative 2 minus rad 5 comma 0 there. So do I have all 5 roots? Yes. Now I'm graphing this one. So my lead coefficient is positive. Odd degree. And I got no doubles in this situation. So there we have that. In this situation, I didn't draw it very low, but my intercept is 0, negative 1,029. I've had a handful of people in my class ask me, how far do I loop up and down? It's a sketch. That's acceptable. If you wanted to in this situation, you could have drew it going like that. Nothing wrong with that. You could have drew it dropping all the way down there and coming up. Whatever you do is fine as long as you label it and we can see what what your ideas are. A few more. Problem 6. Quartic function, negative lead coefficient, all non-zero, including this, which means we have 2 minus 3i, and this, which means we have I. Alright, so time to make our equation. Sum is 4, product is 13, sum is 0, product is 1. So I have x squared minus 4x plus 13 followed by x squared plus 1. Can't forget about our negative lead coefficient. Now it could be negative 1, it could be negative 2, it could be negative a half, whatever you want. I tend to just stick to positive and negative 1 in these situations. So we're not passing through the x-axis, so the only thing we can plot here is our y-intercept of 0, negative 13. You could have, there's a U-shape here if you wanted. Some people like throwing in imaginaries. Whatever you want to do, fine with me. Doesn't matter if you throw in extra loops for imaginaries. Doesn't matter if you leave it just as a downward facing U. Alright, problem 7. Cubic function. 3 real zeros. If I got rad 5, I have negative rad 5, I have negative rad 7, I have rad 7. Alright, here's my issue right away. 1, 2, 3, 4, cubic. Not possible. Right, if it wants 3 real zeros and we end up having, we can't have rad 5 without negative rad 5. We can't have negative rad 7 without rad 7. They come in pairs. There's no way we could have one pair, not the other. So due to that, no actual answer in this problem. Alright, quintic. With one root of -6, a negative lead coefficient. So I got negative x plus 6. And we can't make up extra roots. We can't throw in imaginaries. You can't throw in rads. All we got is -6. So you know what? -6 to the 5th power. -6 comma 0. Going up. Passing through somewhere over here. Find my y-intercept, 0, -7, 7, 7, 6. And there's my acceptable graph. Alright, so today, use the information you have, right? Be specific with what you're doing here. We can't make up random stuff. We can find the pairs. We can add multiples of the roots that we're given. We just can't make up stuff that doesn't exist. Alright? Good luck with this, everybody. If you got questions, reach out.